So type 3 problems have one step that you haven't learned before, and everything else is just the skills you've already learned and already practiced with the first two types. That's why I ask you to please turn in those assignments first so that we can make sure you understand how to do those two types before you move on and try to do type 3 and 4 problems. The first thing we have to do, we're trying to find out when we add these two vectors, what do we get? Well, we can't draw these head to tail and add them because they don't make a right triangle. So what we have to do is find the x and y parts of each vector, add the x and y parts, and then we can add them using vectors because an x and a y do make a right triangle. So we look at this type of problem in pieces, one vector at a time. And again, I'm big on drawing because I feel like it really helps. So this is our 2 at 90 degrees. And breaking this one into x and y is really easy because there is no x. It's pointing completely in the y directions. So we can say x is 0 and y is 2 at 90 degrees. This only works when you have a vector on one of the unit circle lines, 0, 90, 180, or 270. But it does make life a lot easier. Now we'll look at this vector. We have 3 at 48 degrees. So we'll do this one. Draw our x and y. Now all of a sudden this is a problem like we just did, a type 2 problem. The x is the adjacent, and the y is the opposite. And because this is 0 in unit circle, this angle is 48 degrees. Of theta. So in order to find our x, so ka-toa, we do cosine. Cosine of 48 equals x adjacent divided by hypotenuse. So our x equals 2.0. And we have to have a direction. And our x is pointing at 0. And for our y, we're going to do the sine of theta equals opposite divided by hypotenuse. And we get 2.2. At 90 degrees. So far we have not done anything new at all. The new step is right here. We are going to sum the two x and y's. But when we sum these, we have to remember that they're vectors, so they have direction. Now they're going to be in one dimension, left, right, but they do have direction. I find that the easiest way to do this is to think about our coordinates like we would think about a graph. We know if this is x, this direction is going to be positive, and this direction is going to be negative. And if this is our y-axis, this is going to be positive, and this is going to be negative. So when we apply that to unit circle, if x is pointing at 0, it's positive. So this one's positive. If y is pointing at 90, it's positive. So this one's positive. X is pointing at 180, it's negative, and we don't have any of those. And if y is pointing at 270, it's negative. This makes adding them a lot easier. So if we go to our x direction, we just have to simply add them, and then look at the sign to decide what direction they're in. We have 0, it's nothing. So our x direction is just going to be 2, and because it's positive, we know that it's at 0 degrees, according to this. In y, we have 2 plus 2.2, and that equals 4.2, and because it's positive, we know that that's 90 degrees. So this is our sum, 2 at 0 and 4.2 at 90. If using the positive and negative signs convention doesn't really work for you, please send me a message and we'll figure out a way to do it that does work for you. But I find this to be the easiest because when you do graphing in your math classes, this is the way your axes go. This is positive for y, this is negative, and this is negative. So hopefully you can picture that fairly easily. Now we have one more step to do. Now we have a type 1 problem. We have two vectors, an x and a y vector, and we need to add them. We start by drawing our x. We know that's 2, and pointing it this way means add 0. And our y, we know that points up because it's at 90. And we know that this is our resultant. So to find our magnitude, we're using the Pythagorean theorem. 2 squared plus 4.2 squared equals c squared. And we get 4.7. And in order to find our theta, we do TOA. So tangent of theta equals opposite, and if this is our theta, our opposite is 4.2 divided by adjacent. So our tangent of theta is equal to 2.1, and our theta is equal to 65 degrees. And if we think about unit circle, 0, 90, 180, and 270. And we want this angle, which we're already given. So we can say our resultant vector is 4.7 at 65 degrees. This is a lot of work. You can see it's pretty messy, and I tried to change colors to help you track it better. But please do your best to keep your work as organized as possible. One, so that you can look back at the problems when you're studying and see how you did it, and two, so that when I'm grading, if you're making an error, I can see where you're making that error and how to fix it. Make sure that you are showing me quite a lot of this work, because you do have to show work. I need to see your drawings. I need to see you're plugging into the equations in your answers. So please make sure that you're showing me a good deal of this exact work here. If you have questions, please ask for help.